Have you ever wondered why the sun, the very source of our life, sometimes disappears during the day? Well, it all starts with a cosmic dance, a ballet of celestial bodies, if you will. Imagine the sun, the earth, and the moon all swaying in a rhythmic harmony across the vast stage of the universe. Our earth, a twirling blue marble, pirouettes around the radiant sun, while the moon, our loyal companion, faithfully orbits us. But every now and then, the moon, the shy understudy, takes center stage, momentarily blocking the sun's brilliant performance. It's like a well-choreographed dance, where each celestial body knows its place and time. It's a dance that's been perfected over billions of years, a dance that's as old as time itself. It's the dance of the cosmos, a dance that includes us, the spectators, on this tiny sphere we call home, and thus, in this celestial waltz, sometimes the moon cuts in and steals the spotlight. But what exactly happens during a solar eclipse? Imagine a bright sunny day, and suddenly the sun starts to fade. It begins subtly, almost imperceptibly. A small bite appears to be taken out of the sun, as if a cosmic entity was nibbling on our radiant star. This is the partial eclipse, the stage where the moon starts its journey across the sun's face. As the moon continues its celestial dance, it eats away at the sun's bright disk, leaving behind a crescent of light that becomes thinner and thinner. Gradually, the world around us starts to change. The light becomes eerie, like a strange twilight in the middle of the day. Shadows become sharper and the temperature drops. It's as if nature itself is holding its breath, waiting for what's to come. And then, in a moment of dramatic climax, the moon fully covers the sun. For a few precious minutes, day turns into night. We are in the total eclipse, a moment of awe and wonder. Here, the sun's outer atmosphere, its magnificent corona, becomes visible. It appears as a ghostly halo around the moon, shimmering with silvery light. This is the sun as we never get to see it, raw and magical, its fiery power subdued by the humble moon. But the spectacle doesn't end there. As quickly as it started, the moon continues its journey, moving away from the sun. Slowly, the sun begins to reappear. First as a brilliant diamond ring where the sun's light breaks through a valley on the moon's rugged surface. Then as a growing sliver of light as the moon uncovers more and more of the sun. The world around us starts to wake up. The strange twilight fades, the temperature rises, and the shadows return to normal. It's as if we've been on a remarkable journey only to find ourselves back where we started. When the moon finally steps aside, the sun re-emerges as if waking from a brief slumber. Quite the spectacle, isn't it? Now you might be wondering, if this cosmic dance happens so regularly, why don't we see solar eclipses more often? It's a valid question, and the answer lies in a perfect alignment of celestial variables. Let's break it down. First off, size and distance matter. The moon is about 400 times smaller than the sun, but it's also about 400 times closer to us. This cosmic coincidence means the sun and the moon appear to be roughly the same size from our earthly perspective. But this is only part of the equation. The moon's orbit around Earth is not a perfect circle, but an ellipse. This means the moon's distance from Earth changes throughout its orbit. Only when the moon is at its closest point to Earth, known as perigee, does it appear large enough to cover the sun entirely, creating a total solar eclipse. But wait, there's more. The moon's orbit is also tilted by about 5 degrees compared to Earth's orbit around the sun. So, most of the time the moon's shadow either falls above or below Earth, missing us entirely. Only about twice a year, the moon's orbit aligns with the sun and the Earth, creating the potential for an eclipse. However, even these factors don't guarantee a total solar eclipse. Remember, Earth is a big place, and the moon's shadow during an eclipse is relatively small. It's like trying to hit a bullseye with a dart from 200 feet away. That's why the path of totality, where one can see a total solar eclipse, is so narrow, and why any given location on Earth only experiences a total solar eclipse roughly once every 375 years. So a total solar eclipse is not just a cosmic spectacle, but a cosmic lottery win. It's a rare, awe-inspiring moment when the universe lines up just right and we get to witness the extraordinary ballet of celestial bodies in our cosmic backyard. So why do we, puny humans on this tiny rock, get so excited about solar eclipses? Well, it's a combination of their rarity, their beauty, and the deep-seated curiosity that we as a species possess. From the dawn of civilization, humankind has been entranced by solar eclipses. Ancient cultures crafted elaborate myths and superstitions around these celestial events, often viewing them as omens or divine messages. Fast forward to the modern era, our fascination has evolved, but not diminished. Today, we marvel at solar eclipses not just for their awe-inspiring beauty, but for the unique scientific opportunities they provide. Case in point, the total solar eclipse of 1917. This was the event that provided the first experimental confirmation of Einstein's theory of relativity, forever changing our understanding of the universe. In the grand scheme of the universe, we are but tiny spectators. But during a solar eclipse, we get front row seats to one of the greatest shows in the cosmos.